Right, good morning everyone. People, today we're going to focus on trigonometry. We're going to focus on the grade 11 work as well as the grade 12 work. So we're going to start off with the revision of grade 11. Now people, in the first quadrant we get theta 90 degrees minus theta. In the second quadrant 180 degrees minus theta and 90 degrees plus theta. Third quadrant we will look at 180 degrees plus theta as a reduction formula, and in the fourth quadrant we got 360 degrees minus theta and negative theta. Now 270 degrees minus theta and 270 degrees plus theta is not in the syllabus, but if your teachers have taught you that, then you can use it, you may use it, and it will be marked correctly in the final exam. Things to take note of: when we're busy with 90 degrees minus theta and 90 degrees plus theta, we make use of co-functions. We say 90 degrees plus theta is found in the second quadrant. In the second quadrant, sine is positive, but it will change to the cos of theta. 90 degrees minus theta is found in the first quadrant. Sine is positive in the first quadrant, and it will change to the cos of theta. 90 degrees plus theta is found in the second quadrant. Cos is negative, but cos will change to the sine of theta. First quadrant, cos is positive, but it will change to the sine of theta. Now, just take note, 90 degrees plus, 90 degrees minus sine changes to cos, cos to sine, and tan to cot. But that is not in your syllabus, not in the CAP syllabus, it was in the previous syllabus. Let's look at negative theta. Now, negative theta, people, theta is an acute angle. So negative theta is found in the fourth quadrant. So we say, in the fourth quadrant, sine is negative, so it's negative the sine of theta. Negative theta is found in the fourth quadrant, but cos is positive in the fourth quadrant, so it's positive the cos of theta. And negative theta, fourth quadrant, tan is negative in the fourth quadrant, so it's negative tan of theta. Let's look at the compound angle. Now, the cos of A minus B. When it comes to cos, it's cos, cos, sine, sine, opposite sine. So here we can say it is cos of A, the cos of B. If it's negative, it becomes positive, then it becomes sine A, sine B. Right. So cos is cos, cos, sine, sine, opposite sine. If it is a positive here, then it will be a negative here. People, these reduction formulas is on the formula sheet. It's always good to learn the formulas, but if you get stuck, you can always refer to the formula sheet. The formula sheet will be given. Right, in this case here, sine. Sine of A minus B is sine the first, cos the second, keep the sign. Cos the first, sine the second. If it's now a positive here, then it remains positive. For sine, it is sine, cos, cos, sine, keep the sign. Now, in this case here, the double angles, the sine of 2A is 2 sine A, the cos of A. The cos of 2A is cos squared A minus the sine squared of A. It's also equal to 2 cos squared A minus 1. It's also equal to 1 minus 2 sine squared A. So therefore, there are three formulas for the cos of 2A, but there's only one formula for the sine of 2A. Now take note. What they could ask you, and I'm going to do a sum like that, they could say to you, the cos of A minus B is equal to the cos A cos B plus sine A sine B. Derive a formula for the sine of A minus B. So you've got to derive this formula here by using the cos of A minus B. That is a proof. I will do it with you. After we've done this, I will do that specific sum with you. Let's look at the identities. Sine squared theta plus cos squared theta is equal to 1. So cos squared theta is equal to 1 minus sine squared theta. And sine squared theta is equal to 1 minus cos squared theta. People, those are straight identities. And tan theta is equal to sine theta over cos theta. Now, people, I'm going to show you rules that you can use, quick rules that you can use to get to the correct answer. We know that the sine of negative an angle is negative the sine of the angle, correct? But I'm going to teach you a quick rule. I say, if it's a negative angle, we can just add 360 and make it positive. If it is an angle greater than 360, we subtract 360. And if it's not a reduction formula, we add or subtract 360. But before I get to that, I want to explain to you that if you add or subtract 360 degrees, we change nothing. You're allowed to do that because of the following. Right, people, if I've got an angle theta there, that is the angle theta. Now, if I'm there and I add 360 degrees, I'll end up on the same terminal ray. If I'm on this terminal ray and I subtract 360, I go in the opposite direction, I'll land up on the same terminal ray. So do you understand that you're allowed to add or subtract 360 because you land up on the same terminal ray? For that specific reason, we can say, if it is a negative angle, now people, I'm going to do two methods here. I'll teach you both methods in this specific sum. If it's a negative angle, we add 360. So it becomes the sine of 240 degrees. Now 240 degrees, people, we know that 240 degrees lies in the third quadrant. 0 to 90, 90 to 180 is the second, 180 to 70 is the third quadrant, 270 back to 360 is the fourth quadrant. 240 lies in the third quadrant. It lies between 180 and 270. So we use the third quadrant's reduction formula to get it to an acute angle. So this becomes the sine of 180 degrees plus theta. And theta must be 60 degrees because I need to get an angle of 240. In the third quadrant, sine is negative. It's negative the sine of 60. And the sine of 60 is root 3 over 2. Now, people, root 3 over 2, you can use your special angle triangles, or you can just use your calculator. Even if they say do not use a calculator, take note. Even if they say do not use a calculator, you can use it, provided you do the following. If it's sine of 240, I cannot go straight away to negative root 3 over 2, because then they say you used your calculator. But if you show the acute angle, if you go from sine of 240 to negative sine 60, and then use a calculator, you get full marks. Is that clear? So you're allowed to use your calculator, even if they say do not use a calculator, provided you always express your angle as an acute angle. Is that clear? Right, next. People, if an angle is greater than 360, the rule is you're going to subtract 360. So the 420 degrees becomes the tan of 420 minus 360 becomes the tan of 60. And the tan of 60 degrees becomes opposite over adjacent, which is equal to root 3 over 1. Is that clear? So please make sure that you express it as an acute angle, then you may use your calculator, even if they say do not use a calculator. Next. Now, people, for this specific sum, I'm going to do the following. I'm going to do the method that your teacher might have taught you. If they say to you, the sine of negative 120 degrees, we said the sine of negative an angle is negative the sine of the angle. Negative the sine of the angle, correct? And the sine of 120 is found in the second quadrant. The second quadrant's reduction formula is 180 degrees minus theta. Now the sine of 180 degrees minus theta in the second quadrant, sine is positive. It's positive the sine of theta. And a positive times a negative is negative the sine of theta, which is negative root 3 over 2, and that gives you the same answer. Is that clear? So your teacher might have taught you this method, but the quick method that you can also use and you'll always get the right answer. If it's a negative angle, add 360, angle greater than 360, subtract 360. Now let's look at this one here. If it's not a reduction formula, we can add or subtract 360. Now people, there is always a question where you're going to make use of negative angles, angles greater than 360, not a reduction formula. So take note, 7 to 8 marks in every single exam, including the November final exam, you will get this kind of question. Now, people, the sine of 540 degrees minus theta. Do you understand that that is not a reduction formula? The reduction formulas is theta, 90 degrees minus theta, 90 degrees plus theta, 180 degrees minus theta, 180 degrees plus theta, and negative theta. Those are the reduction formulas. So this is not a reduction formula. Now, do I add or do I subtract? That's the question. Theta is always an acute angle. An acute angle is an angle between 0 and 90. So 540 minus an angle between 0 and 90 is an angle greater than 360. And how do I work with an angle greater than 360? I subtract 360. So this is not a reduction formula. I must add or subtract 360 because this angle is greater than 360. I subtract 360, so it becomes the sine of 180 degrees minus theta. Are you with me? So now that is a reduction formula. So 180 degrees minus theta is found in the second quadrant. Sine is positive. It becomes positive the sine of theta. Are you with me? Right, the tan of theta minus 360. People, that is not a reduction formula. Yes, you can take out a negative. You can say the tan of theta minus 360 is the tan of negative bracket 360 degrees minus theta, and the tan of negative an angle is negative the tan of the angle, so it's negative the tan of 360 degrees minus theta, but the tan of 360 degrees minus theta is negative theta. Negative negative theta is positive theta, and you've got your answer. Or you can just say, this is not a reduction formula. Must I add or subtract? Because theta is an acute angle, an angle between 0 and 90, minus 360 is a negative angle. And how do I work with a negative angle? How do I work with a negative angle? I add 360. So this is not a reduction formula. I must add or subtract. What do? I add. I add 360. It becomes the tan of theta. All right. So instead of the long method, which I just explained to you, tan of theta, you could take out a negative there, and then you could work the long method. Just use add or subtract 360 if it's not a reduction formula. Let's look here. People, here we got the cos of theta minus 180. That is not a reduction formula. 180 degrees minus theta is. We're not going to take out a negative. We can do that. Then it becomes the cos of negative bracket 180 degrees minus theta. And the cos of a negative angle is positive the cos of the angle, so it's positive the cos of 180 degrees minus theta, which is equal to negative cos theta. Or you can just do the following. You could say, not a reduction formula. If it's not a reduction formula, I must add or subtract. Now, do I add or subtract? Theta is an acute angle. An acute angle minus 180 is a negative angle. How do I work with the negative angle? I add 360. So if I add 360 to that, it becomes the cos of theta plus 180 degrees. Are you with me? Right. Now that is equal to the cos of 180 degrees plus theta, correct? And in the third quadrant, cos is negative, so it's negative the cos of theta. Are you with me? Are you happy? All right. So people, quickly. In summary, if it's a negative angle, what do? Add 360. Angle greater than 360, what do? Not a reduction formula, what do? Add or subtract. And always use, how do I know whether I need to add or subtract? Use theta as an acute angle, and then you know, am I busy with an angle greater than 360 or an angle less than 360? Correct, a negative angle. All right, people, are you with me? Now, the exception to the rule is the following. Now, I know people that in some schools, your teacher teaches you 270 degrees plus or 270 degrees minus for the specific reason of this. Let me explain to you. The exception to the rule is the following. Now people take note, you're going to get this, guaranteed. 5 to 7 marks in every single exam from now on until November, including November. All right, have a look. The exception to the rule is, if I've got theta minus 90 degrees. Right, people, here we can say, this here becomes the sine of theta minus 90 degrees. People, in this case, it's not a reduction formula, but if it's theta minus 90, I'm going to take out a negative. The sine of negative 90 degrees minus theta. Now take note. Negative times 90 is negative 90. Negative and negative theta is plus theta, correct? Now it becomes the sine of negative an angle, correct? And the sine of negative an angle, fourth quadrant, sine is negative, negative, the sine of the angle, correct? So here we can say, sine of 90 degrees minus theta, first quadrant sine is positive, but sine changes to cos theta, so it is negative the cos of theta. That there is positive cos theta. Times the negative is negative cos theta. However, some teachers teach, now I'm not going to ask which schools, it's not in the CAP syllabus, but if you want to use it, in the final exam, we will mark it correct. People, even if you do AP maths and you come up with strange concepts, right, if your answer is correct and your working is correct and it's not a method that is used in the textbook, but perhaps in an AP textbook, it will be marked correct if it's mathematically correct. Okay, so it doesn't matter which methods you use. If it's right, you will get your marks. Let's look at the following. We could keep to the rule there. Theta minus 90 degrees. Right, now people take note. I'm going to keep to the rule if it's not a reduction formula, we add or subtract 360. So take note. Theta is an acute angle. Minus 90 is a negative angle. So what should I do? Add 360. So it becomes the sine of theta minus 90 degrees plus 360 degrees becomes the sine of theta plus 270 degrees, and that is equal to the sine of 270 degrees plus theta. Now the sine of 270 degrees plus theta, people, works for 90 degrees plus 90 degrees minus theta, 270 degrees minus theta, and 270 degrees plus theta. For those four, I use my co-functions, correct? So I can say, excuse me, I can say, in this case, 270 degrees plus lies in the fourth quadrant and sine is negative, but sine will change to the cos of theta. Now you can see this specific sum and this specific sum has got the same answer. Is that clear? So if your teacher did not teach you 270 degrees minus or 270 degrees plus, don't use this method. The exception will be theta minus 90. Is that clear? Just take out a negative. Do you understand that? Right, people, let's do the next. Are you happy with that? Right. People, the square and then the co-function, and then we can delve into past paper questions. Right, people, it's quite easy. You need to follow the rules that your teacher has taught you. Don't come here and try and learn new things and get confused. All right, let's reinforce the methods that your teacher has taught you at school. But if you find that you're sharp enough to be able to learn a new method and it's easier for you, then go ahead and do that. Right, let's look at the following. People, a square. Every time you get a square, then the rule is the square goes outside the bracket. For example, here we got the sine squared of 180 degrees. People, I'm going to change the sum in the notes to plus theta. So what we're going to do is we're going to say it is the sine of 180 degrees plus theta, and we said the square goes outside the brackets. Instead of the square there, we keep it as the sine of 180 degrees plus theta, the square goes outside the brackets. Now, this here is in the third quadrant, sine is negative sine of theta, and then we square it. Negative squared is positive sine squared theta. Right, are you happy? Right, people, let me just explain to you co-functions, and then we can start. The sine of 10 degrees is the cos of 80 degrees. Now, people, take note in terms of co-functions. We know that sine and cos are co-functions. Now, when are co-functions equal? If the two angles add up to 90. Right, on your calculator, I want you to key in. Now, when you use your trig functions, you must be on the deg function, not on the rad or grad, the deg function. On your calculators, I want you to key in the sine of 10, quickly, sine 10. What's the answer? Right, cos of 80, key it in. Right, do you see it's the same answer? So people, the co-functions are equal if the two angles add up to 90. So please help me here. The sine of 30 degrees is the cos of how many degrees? 60. Right, people, the sine of 30 degrees is equal to a half. The cos of 60 degrees is also equal to a half, correct? Let's do the last one. The cos of 5 degrees is equal to the sine of what? 85 degrees. Sine and cos are co-functions, and if the two angles add up to 90, then the co-functions are equal. Right. Are you happy with that? Now, I just want you to look at the following. People, I'm going to remove all the theory now. It's in front of you. We're just going to do past paper questions. This past paper question is not in the notes, but I need to do it because you need to be able to prove the different compound angle identities. So I want you to write down the following. Right, people, if they say to you, right, given, if they say to you, given the cos of A minus B is equal to cos A cos B plus the sine of A, the sine of B. All right. That is given. We need to determine a formula for the sine of A minus B. Right, please take note of this. Right, people, here we can say that the sine of A minus B. Now put down your pens and just listen, and once you understand it properly, you may copy it. But please, you cannot multitask. Right, let's quickly have a look at the following. People, we got to find a formula for the sine of A minus B. But what do I need to do? I need to change this to the cos of this angle, to a cos of an angle minus an angle. Because then I can just use this. Do you understand? So to find a formula for the sine of A minus B, I must change it to the cos of an angle minus an angle. So therefore, what are we going to say? That the sine of A minus B is equal to the cos of (90° minus A minus B. Now people take note. Do you understand that the cos of 90 degrees minus the angle, this is equal to positive the cos is positive the sine of the angle. The cos of 90 degrees minus the angle is equal to positive the sine of the angle, correct? Now, I need to change this to an angle minus an angle. So I'm going to say this is equal to the cos of 90 degrees minus A plus B, correct? Now people, for it to be an angle minus an angle, A must be in the first angle and B must be in the second angle. So it is equal to the cos of 90 degrees minus A minus B. Take note. People, this here, 90 degrees minus A is there, and plus negative times a negative is plus. Now it's equal to the cos of an angle minus an angle, where A is in the first angle and B is in the second angle, correct? Now I can just follow this rule. What is the rule? It's cos the first, cos the second. Cos the first, cos the second. Plus sin the first, sin the second. Now we can say the cos of 90 degrees minus A. Now we're going to make use of the cofunctions. First quadrant cos is positive. It's going to change to the sine of A. The cos of negative B, fourth quadrant cos is positive. So that is going to be positive, the cos of B, correct? And then we're going to say this here, the sine of 90 degrees minus A, first quadrant sine is positive, but it's going to change to the cos of A. And this one here, the sine of negative beta, fourth quadrant sine is negative, so it is negative the sine of beta. Now we can keep that positive sign there. Now we can take it further. This here is equal to sine A, the cos of B, and a positive times a negative is a negative. Negative times a positive is a negative. Cos A sine B. And we know that the cos of A minus B is cos the first, cos the second, keep the sign, cos the first, sine the second. So it is sine, cos, sine, opposite sign. Have you got it? So we've proved it. Now people, you must be able to prove all of them. You must be able to prove that the sine of A plus B and the cos of A plus B, all of them must be proved from the cos of A minus B equal to cos A cos B plus sine A sine B. Go, these are proofs. It's in your book. Go and study it. It has been asked on a number of occasions. Please make sure that you know those proofs. Let's look at the following. Right, now people, the last section of work on grade 11 before we start the grade 12 work is the following type of sum. I'm going to leave it there so that you can copy whatever you need to copy. If you go and study these rules, people, there's not much else that needs to be studied. Then you've got all the tools needed to answer the questions. Let's look at the following. If the sine of 30, now people, this question, I changed the question that was here at the bottom, because the one at the bottom doesn't cover every different type of question. So I've added a question. I want you to copy this question as well. It's not in your notes. Right, it says, if the sine of 36 degrees is equal to m, express the following in terms of m. Right, let's quickly have a look at this. I need your attention. Now, people, this example here covers all the possibilities, okay? And I'm going to show you how to reason with respect to this one here. Let's quickly have a look. The sine of 30 degrees is equal to m over 1. So 36 degrees is found in your first quadrant, so that is 36 degrees. Now the sine of 36 is opposite over hypotenuse. Opposite is m, hypotenuse is 1, and I'll work out x using Pythagoras. So we can say that x squared is equal to r squared minus y squared, which is 1 squared minus m squared, which is 1 minus m squared. So x is equal to plus minus the square root of 1 minus m squared, and we know that x is positive, so it's only equal to positive the square root of 1 minus m squared. Right, is that clear? So once you've got x, y, and r, you've got that 36, that is 90, so you need to determine the angle on top. So the angle on top is equal to 54 degrees. The sum of the interior angles of a triangle add up to 180. Now, this is the way you need to reason. You say, the first step, people, that you get, once you've got this and you've got the diagram and you've got x, y, and r values, you've got to express the cos of 216 degrees in terms of m. Now take note. The first step is to get that angle, to make that angle an acute angle. This is found in the third quadrant, so we use the third quadrant's reduction formula, 180 degrees plus, in this case, 36 degrees. Now, in the third quadrant, cos is negative, the cos of 36 degrees. Once you've made that angle an acute angle, is that acute angle found in the diagram? Yes. So we can use the diagram. The cos of 36 is adjacent over hypotenuse, so it is negative the square root of 1 minus m squared over the hypotenuse, which is 1. Are you happy? So the first step is always to make that angle an acute angle. Now, people, this specific sum here, 108 degrees, there's two methods for the sum. So take note. Yeah, the first step is to make that angle acute. It's found in the second quadrant. I need to use the second quadrant's reduction formula. It is the sine of 180 degrees minus 72 degrees, which is the sine of 72 degrees. Now people take note. We made that angle an acute angle. Is that acute angle in the diagram? No, it's not found in the diagram. If it's not found in the diagram, we look for a double angle. Double the angle in the diagram. So this here becomes the sine of 2 times 36 degrees. 2 times 36 is equal to 72, correct? Now this here is a double angle. The sine of 2 theta, which is equal to 2 sine 36 degrees, the cos of 36 degrees. Are you happy? And the sine of 36 degrees is m over 1. And the cos of 36 degrees is equal to the square root of 1 minus m squared over 1. The answer is 2m, the square root of 1 minus m squared. Right, is that clear? I repeat. The first step, 1.1, always make the angle acute. Look at the acute angle. Is it in the diagram? Yes, use the diagram. In the second one, we make that angle acute. So we're going to use our reduction formulas. 108 degrees is found in the second quadrant. Second quadrant's reduction formula is 108 degrees minus theta. So we made it acute. But that acute angle is not in the diagram. So we look for a double angle. 72 is 2 times 36. It's double the angle of an angle in the diagram. So I use my double angle identity. The next one. The same with this. I'm going to lift it now. The same with this. It is an acute angle. Acute angle is not in the diagram. So therefore, it is a double angle. This here is equal to the cos of 2 times 36 degrees. Now people, there's 3 formulas for the cos of 2 theta. It's cos squared 36 degrees minus sine squared of 36 degrees. It's 2 cos squared of 36 degrees minus 1, or 1 minus 2 sine squared of 36 degrees. Any of the 3 can be used. I will use 2 cos squared 36 degrees minus 1. So this here, the cos of 36 degrees, I can use the diagram. It's the square root of 1 minus m squared over 1 to be squared minus 1, which is 2, the square root of that is 1 minus m squared minus 1, which is 2 minus m squared minus 1, which is equal to 1 minus m squared. So people, whether you use 2 cos squared 36 degrees minus 1, or cos squared of 36 degrees minus sine squared of 36 degrees, or 1 minus 2 sine squared of 36 degrees, the answer will be correct. Do you understand that? You want to ask a question? Would you like to answer? Do you understand that? Right, people, let's look at the cos of 84 degrees. Now, this is the third option. The first step is to make that acute. Is it acute? Yes. An acute angle lies between 0 and 90. It is acute. Does that acute angle lie in the diagram? No. Is it double the angle in a diagram? No. So the third option is a special angle plus an angle in the diagram must give you 84. So if I use 54 plus 30, that will give me 84. So it's the cos of 54 degrees is an angle in the diagram, plus 30 degrees is a special angle. So if I cannot get a double angle, it's a special angle. What are special angles? 30, 60, 45. Those are special angles. Plus an angle in the diagram. Either 36 or 54 must make up the number. Correct. So 54 plus 30 will make up the number. So this is the combination I will use. And this here is a compound angle. So now we can say the cos of A plus B is cos the first, cos the second, opposite sign, sine the first, and sine the second. People, are you with me? Right, now the cos of 54 degrees is m over 1, adjacent over hypotenuse. The cos of 30 degrees, in this case, is equal to root 3 over 2. The sine of 54 degrees is the square root of 1 minus m squared over 1 times the sine of 30 degrees, which is a half. So here we can say that times that is root 3m minus the square root of 1 minus m squared, and your LCD is 2. People, that there, m times root 3 divided by 1 times 2 is 2. So it is m root 3 over 2 minus the square root of 1 minus m squared over 2, LCD 2, final answer. Are you happy with it? Okay, people, do you understand my reasoning? Just take note, I'm going to just explain it once again. It's quite easy. Yes? All right, thank you. 2 minus 2m squared. Thank you. Right, let's quickly have a look at the following. People, once you've got your diagram in terms of x, y, and r, the first step, you always make the angle acute by using the reduction formula. If the acute angle is in the diagram, use the diagram to get the answer. In the second one, people, the first step is to make it acute. Is the acute angle in the diagram? No. Then we look for a double the angle in the diagram, 2 times 36 or 2 times 54. So it's 2 times 36 in this case, and we can work it out. You could have also used this side to the sine of 2 times 54, and it would have also given you the correct answer. In this case, people, once again, it's a double angle. It is an acute angle. It's not acute angle in the diagram, so we use an angle in the diagram to give you 72. The third one, if it's not double the angle in the diagram, then we use a special angle plus an angle in the diagram, and then we make use of the compound angle formula. Is that clear? Either sine or cos. Are you happy with that? That covers all the possibilities. However, take note of the following, and I want you to write this down. We're all aware that the sine of 2 theta is 2 sine theta cos theta. People, we're all aware of that, correct? Now take note. If I halve this angle, then I get the sine of theta. Then I must halve these angles too. It's 2 sine of theta over 2, the cos of theta over 2. Right, take note of that, please. I want you to write it down. Next, the cos of 2 theta is equal to, we know, cos squared theta minus sine squared theta, correct? So the cos of theta is equal to cos squared theta over 2 minus the sine squared of theta over 2, correct? The cos of 2 theta is also equal to 2 cos squared theta minus 1. If I halve this angle, then I must also halve this angle. And the last one, the cos of 2 theta is equal to 1 minus 2 sine squared theta. So therefore, the cos of theta is equal to 1 minus 2 sine of theta over 2 squared. Right, just take note of this. Right, people, in the September paper of last year, this question was used. Is that clear? Where they give you a special angle, they give you 14, and now they're asking you the cos of 7. You understand? So take note, make sure that you are able to use it when we get specific angles in place of theta. Okay. What I want you to do, people, I want you to go and work. I'm going to focus once again on the first sum. I'm going to do the first sum with you, Yam. And when is it undefined? Let's take it from there. I'm going to focus, please make sure that these notes are here next week. Bring the same notes next week. We're going to do the grade 12 sums. Out of this, I will also collect more material, and I will also give you the mark allocation per topic, if it hasn't been given to you. If you are writing the departmental exam, I will give all that information. If you are writing your own school exam, then obviously your teacher will guide you on the mark allocation. Let's look at the following. Right, people, can I get your attention on this one, please? They ask that, just like that, in the grade 12 exam. March, June, September, November. Let's take note of the following. People, in this case, we got to simplify. So let's quickly go through the rules together. Now, what I want you to do, people, if there's multiplication between the terms, then I want you to put it in brackets. For example, 90 degrees plus x is found in the second quadrant. Sign is positive, but it will change to cos x. It's a bracket times a bracket times a bracket squared, correct? Divided by a bracket times a bracket minus 1. Put it in brackets, otherwise with the signs there, you don't know whether you're adding or subtracting. We are multiplying. On top, yeah, we're multiplying, yeah, we're subtracting 1. So in this case, negative x is found in the fourth quadrant, cos is positive, positive the cos of x. Now, people, take note. 540 minus x, it's not a reduction formula. If it's not a reduction formula, we must add or subtract 360. What must we do? Subtract 360. The square must go outside the bracket. So this here becomes the tan of 360 degrees, or 540 minus 360 is 180 degrees plus x, correct? Does it make sense? Right. The square goes outside. This here, second quadrant cos is negative, negative the cos of x. This here is the exception to the rule. Yeah, we can take out the negative. So it becomes the sine of negative 90 degrees minus x. But the sine of negative an angle is negative the sine of 90 degrees minus x, which is the cos of x, correct? Does it make sense? Right. Now, we can say this here is equal to cos squared x. Cos x times cos x is cos squared x times tan of 180 degrees plus x is found in the third quadrant. Tan is positive, positive the tan of x squared. So it is positive tan squared x. A negative times a negative is a positive, so it is cos squared x minus 1. Are you happy with that? Right, people, I'm just going to continue. Yeah? This becomes the cos squared x times the tan x is sine squared x over cos squared x, that cancels out. And cos squared x minus 1 is equal to negative sine squared x. So it becomes sine squared x over negative sine squared x, which is equal to -1. Now, people, just take note of this. Let me explain to you how that works. Here we've got sine squared x plus cos squared x is equal to 1, correct? Now, if we take that across, cos squared x minus 1, then we must take that across, negative sine squared x, correct? Does it make sense? Right. Now, people, they say, for which values of x is it undefined? It is undefined if the denominator is 0, correct? So I can use that denominator, or I can use that denominator to work it out. It doesn't matter. I'm going to do both. Let's look. Now, here we get cos squared x minus 1 is equal to 0. It is undefined if the denominator is equal to 0, and now I solve for x. So now we can say it is cos squared x is equal to 1. So therefore the cos of x is equal to plus minus the square root of 1, which is 1, correct? Now, you can say, what is your reference angle? Your reference angle is 0 degrees. You can say shift cos of positive 1. So the reference angle is equal to 0 degrees, correct? So in the first quadrant, what have I got? In the first quadrant, I've got 0 degrees. It's positive. Cos is positive, 1, yeah and yeah. And in the third quadrant is 360 degrees minus 0, which is 360 degrees, correct? So these are my two solutions so far. Now cos is negative 1, is negative in the second quadrant. So it's 180 degrees minus theta, which is 0 degrees. That gives you 180 degrees. And the third quadrant, cos is negative. 180 degrees plus 0 degrees is equal to 180 degrees. So what's your solution? 0 degrees, 360 degrees, or 180. So here we can say x is an element of 0 degrees, 180 degrees, and 360 degrees, correct? Right, what you could have also done, you could have drawn the cos graph. You could have drawn the cos graph. You could have said, I'm going to draw the cos of x is equal to cos x is equal to plus minus 1. Okay, do you understand that step is this step here? Now I'm going to draw the cos graph. I'm going to draw the graph of y equal to the cos of x. Now people, if we just look between 0 to 360, the cos graph starts at the amplitude, which is 1. It goes through 90. It turns at 180. It goes through 270. And then it lands up again at 360. So it goes through 90, turns at 180, through and back there. So when is it 1? It's 1 at 0 degrees. When is it 1? 360 degrees. And where is it negative 1? 180 degrees, correct? So the answer here, when is it 1? At 0 degrees and 360 degrees. When is it negative 1? At 180 degrees. And that gives me my solution. Whether I do it graphically or whether I do it algebraically, the answer is correct. I could have also used this line here, negative sine squared x. So you say negative sine squared x is equal to 0, sine squared x is equal to 0, sine of x is equal to plus minus the square root of 0, which is 0, and I can draw the graph for sine x equal to 0. Okay, people, we will see you next week. Please bring the same notes. I'm going to do every different type of question. Bring this with, and I will add to this in next week's lesson. Thank you.